in a straight path endlessly on both the directions is called as line. The set of points in a plane. Plane is a flat surface. In a flat surface, plane, the set of points in a straight path endlessly on both the directions. We call it as a line. Line has infinite set of points. It doesn't have any end on both the sides, so it has no end points of it. So this is a line we call. Line we can name it as AB. AB is a line. So we will represent the line. The symbol of line is in this form, which has arrows on both the directions. So angle, we take any two lines and have one common point of it. It's called as angle. Those two lines are intersecting at a common point. At a common point makes an angle. So it forms an angle. So two lines are intersecting at one point. So it has one common point as O, and the angle formed is angle AOP. So AOP is an angle we call. So angle AOP, or we can call it as BOA, angle AOP or angle BOD. So everything, so both are equal. So we can call this angle as AOP and BOA. So when two lines are intersecting, the two lines will form an angle. So this is one angle, and just exactly opposite to it, there is another angle is formed. That angle is we take it. These angles are called as vertically opposite angles. So let's draw extension of these two. So these are called as vertically opposite angles. So they are exactly opposite to each other. So they are not adjacent angles. So adjacent angles are nothing but they have a common arm and common vertex. So we call them adjacent angles, and it will form linear pair. So the linear pair so forms an 180 degrees. So these are exactly opposite. We are discussing about opposite angles, vertically opposite angles. They are vertically opposite. So these are equal. So let's name this something CD, C and D. So angle AOB is equal to angle COD. AOB is equal to angle COD. These are the vertically opposite angles we form. For example, we take any angle here, 30 degrees. We get angle AOB 30 degrees, and COD also becomes 30 degrees. So these both vertically opposite angles are equal. If we take any one of the angle here, AOB is 30, then we can find out angle AOC also, because it has a linear pair. So we have discussed about the linear pair. So linear pair of angles, the two angles are formed with the adjacent. They are adjacent to each other. They have common arm and common vertex. Linear pair. So they have a common arm. Common arm is OA. So common vertex is O, and both the angles, angle AOB and angle AOC, AOB and AOC, these two angles have a common arm of OA. OA is a common arm and vertex is O. So these two angles are having common arm of OA, and the common arm is OA and common vertex is O. So these two are called as adjacent angles, and these two adjacent angles will form a linear pair, because two angles, adding the two angles will be getting the 180 degrees on a straight line, on a straight line. So COD is a straight line. On a straight line, the two angles are formed, and both the angles are equal to 180 degrees. So this obtuse angle, acute angle, will form a straight angle. So let's take this one as x. Let's find out this x value as AOC. So we know that it's linear pair, and if we add of these two angles will be getting 180 degrees. So angle AOB plus angle AOC is equals to 180 degrees. So we know that is angle AOB, that is 30 degrees. 30 degrees plus angle AOC is 180 degrees. And after transposition, we'll be getting angle AOC as 150 degrees. So this is 150, x is 150 degrees. So x is written as 150 degrees because just as we know this is a straight angle, a linear pair will form a straight angle. So x plus 30 is 180 degrees and 30 plus 150 directly we can get it. Just in a logic, it's a straight line. A COB is a straight line. Just look at here. It's a COB is a straight line, and then on a straight line, the angle will form is 180 degrees. And then here already we know it's a 30 degrees angle. AOB is a 30 degrees angle, and then VOC will be 150 degrees because both combining 180 degrees we get. So in this manner, we got x value and VOC. And as we know, vertically opposite angles are equal. We have discussed two lines are intersecting, and then we call them intersecting lines. And these intersecting lines, which are not adjacent and which are opposite to each other, we call them vertically opposite. These are x and x, and this is y and this is y. If vertically opposite angles are equal, the two lines are intersecting in this manner. So similarly here, we have discussed about angles COD and angle AOB that are equal, 130 degrees. And similarly, let's find out the vertically opposite angle to AOC is angle BOD, that is 150 degrees, as we know, because it's vertically opposite to COD. So this is 150 degrees. As we know, it's a complete angle. If you add all the four angles, we get here 4 angles are formed. When the two lines are intersecting, 4 angles will be formed. All the 4 angles are added will be getting 360 degrees. Just we can find out, and that is 30, 150, 180. And this is, we know that here 30 degrees. Already we have discussed about it. And this is 30, so 180 and 30 plus 150, 180, 180 plus 210, 210 plus 150, 360 degrees, and completely the angle is formed is 360 degrees. And this is a concept of vertical opposite angles in the linear pair. We have discussed vertically opposite angles. We have discussed and the linear pair, and we have discussed. And this if we get any problem, we'll solve in this manner. Let's go to the complementary angles and supplementary angles. As we know, the linear pair will come with the linear pair. If two angles, add two angles and we get 180 degrees, we call them straight angle, straight line. On a straight line we get 180 degrees. And if we add two angles, like for previously we have taken 30 and 150, we got 30 and 150. And just if we add two angles and get 180 degrees, the sum of two angles is 180 degrees, and we call them supplementary angles. They are supplement to each other. So just repeat it, make name for it. This A, B, C, and then we call it here angle AOB and angle BOC are supplementary to each other. They supplement to each other because if we add the two angles and we get 180 degrees, we call them supplementary angles. And let's go to the next one, complementary angles. If we add any two angles, we get 90 degrees, we call them supplementary angles, complementary angles. And this is third. Let's go to the next concept, that is complementary angles. If we add two angles and get the sum of the two angles is 90 degrees, and we call them complementary angles. For example, we take right angle, and we see here this is 30 degrees and 60 degrees. We add these two angles and we get 90 degrees. The sum of two angles is 90 degrees, and we call them complementary angles. And then let's take the name of it, AOB, and BOC, and AOB and BOC are complement to each other because if you add AOB and BOC, will be getting 90 degrees, and that's the reason we call them complementary angles. Up to now we have discussed about vertically opposite angles and linear pair of angles, and supplementary angles and complementary angles. Vertically opposite angles, just which are opposite to each other, but two lines are intersecting, and which are opposite to each other, we call them vertically opposite angles. Linear pair of angles, the two adjacent angles having the same common arm and the common vertex, we call them linear pair, and the sum of two angles is 180 degrees, and we call that a linear pair of angles. And supplementary angles, the sum of two angles is 180 degrees, and we call them supplementary angles. And the sum of two angles is 90 degrees, and we call it complementary angles. Let's go to the next concept. Let's discuss about the transversal. The two lines are intersecting and two distinct points. For example, we take two lines in a plane intersected by some other line, third line, and two distinct points. They are intersecting at two distinct points. Let's name it as something. For example, A, B, C, D angles will be formed, four angles will be formed. As we discussed earlier, and two lines are intersecting and four angles will be formed. Here we have two lines. These two lines are intersecting and four angles will be formed. Similarly here, four angles will be formed, and the two lines are intersected by another line at two distinct points, and this is called transversal. And let's name it as L and N, and N is intersected by L and N are intersected by the transversal line N. So at two distinct points. So let's name some of the angles here. Four angles will be formed. That is A, B, C, D, and E, F, G, H. And let's discuss about the angles which are formed here. And here, interior of the two lines, we call them interior angles, that are CD, EF. CD, EF are inside of the transversal, inside of the transversal line, or inside of the two lines which are L and N, between them. So these are called as interior angles, and these all the angles are called, these four angles are called as interior angles, CD, EF, and which are outside of the two lines. We will have the two lines L and N. Outside of L and N, we have some of the angles which will form, that are AB and GH. These are called exterior angles. So interior angles and exterior angles. Let's discuss about some more angles about N, that are other two angles are formed. One is interior and another is exterior at the same side of transversal, and we call them corresponding angles. For example, angle A and angle B are corresponding angles. Let's discuss again. At the same side of transversal, one of the angle is interior, other angle is exterior. We call them corresponding angles. One angle is interior, angle E is interior, angle A is exterior, and one of the angle is interior, another angle is exterior, and they are both the same side of transversal line. So we call them corresponding angles. Let's find out all the corresponding angles in this transversal line. There are angle B and angle F are corresponding angles, and these two pair of angles are called, this pair of angles are called as corresponding angles. Angle B and angle F, and angle A and angle E, and angle C and angle G, angle C and angle G, and angle D and angle H. So let's see what are the angles are formed here. Angle A, angle E, and angle B, angle F, angle C, angle G, angle D and angle H, and these all the angles are called as corresponding angles. Let's see. Which are exactly opposite to that property. interior and other is exterior, and they are at the same side of transversal line. But here we need to take exactly opposite to that property, that are both angles are interior and they are either side of transversal. We call them alternate angles. For example, if we take angle C and angle E, they are either side of transversal. Angle C, angle E. Angle C and angle E, these are either side of transversal line. So different side of transversal line, and they are both are interior angles, and this kind of angles are called as alternate angles. Some more alternate angles are angle D, angle F, and angle A and angle G, and angle B, angle H. These all angles are called as alternate angles. So let's recall again: angle C and angle E, angle C and angle E, angle D, angle F, and angle A, angle G, angle B and angle H. So these kind of angles are called as alternate angles. And let's go to the next one. Under exterior angles and interior angles we have discussed, and corresponding angles we have discussed, and alternate angles. And let's go to the next concept.